Awesome, guys. Thank you all for joining. So, in this webinar, we will be modeling the Apple Watch strap pattern. Okay, we have created our own pattern design. And in this webinar, I'll show you a specific workflow which creates amazing result with very less effort. All right. So let's see how we can do it. So thank you all for joining in. I can see you're joining in from everywhere. So great to see you all, especially our ex-students. So let me quickly introduce myself. I'm Aman. I'm an industrial designer. I've worked with companies like Logitech, PA Consulting, Bosch and Siemens, and I help these design teams apply textures on their products. As my primary CAD tool, I've been using Rhino and Grasshopper. So while working with these clients, whatever I learn from doing these projects at Academy, we share it with you guys. So Academy is an online 3D school trusted by more than 2,000 designers. We also have some ex-students joining us in the webinar. And we have been running Academy for the past 5 years. The team consists of me and my co-founder Estella. So we provide live Rhino and Grasshopper training for you as a designer and a design professional, as well as to your teams. Okay. So you can check our webpage if you are interested in learning more about our courses. We have some additional resources as well and other past free webinars. You can also follow us on our social media to be up to date about our courses, about new workflows, about articles. We share some inspirational works as well, students' works as well. So please follow us at Creative Mutation, me, and at Academy to the school. So let me quickly take you through what you can learn at Academy. So these are some of our courses. All of these courses are live, where I help you learn how to use these CAD softwares. So we have Rhino, Grasshopper, and KeyShot, ideal for beginners, and texture and computational design workflows for advanced users. We will talk about these courses later on in the presentation. So let's get started with the webinar. First, check your inbox and make sure you have downloaded the zip file. Okay, so this is the zip file. And if you unzip it, you should see these 3 files inside the folder: the Rhino file, the Grasshopper file, and the KeyShot file. Maybe you don't have KeyShot, so it's fine. I'll show you the workflow. And later on, once you download KeyShot, the trial version, you can try it on your own. If you are unable to download the resource files, I have pinned a temporary link and you can use that. But if you're watching the stream afterwards, you have to download it from our webpage. Everybody, were you able to download the zip file? Okay, let me know. So in this one, we will learn how to create this fading texture on the Apple Watch strap. Okay, so let's first focus on what the problem is when we have to create these kind of textures. All right. So the first problem is when you have to make these iterative textures, it's a manual sculpting process. Okay, so you have to sculpt it one by one. You have to select the edges and then maybe the cross-section profile, and then you have to sweep or loft the surfaces. So it's a slow, repetitive, and error-prone process. Apart from that, if you are using sweep and loft tools, you need 4-sided boundary. So if you are familiar with the NURBS topology, in order to create a sweep or loft, you need always 4 sides. Where in some of the textures, as you can see here, you are never or not necessarily going to make 4-sided boundary. Okay, so that is another bottleneck here. Apart from that, we need manufacturable textures in NURBS and not mesh displacement. So if you have used other rendering softwares like KeyShot, you can apply a UV texture and then just use a bump map or displacement map. But in case of manufacturing, you do need the NURBS data so that you can export the step files. Okay, so what is the solution here? Well, we will be using the patch command. Now, patch command is not that famous for creating high quality surface, but in this webinar, you will see how can we use this simple yet effective command to create complex textures in very easy steps. Before I explain you that, let me quickly recap what is the NURBS topology of a surface. Okay, so a NURBS surface is always defined by 4 boundaries. You can see here the 2 green curves, so curves in the U direction or the boundaries in the U direction, and the 2 red curves, the boundary in the V direction. Okay. Now, what if you have a non-4-sided boundary? So if you have to create a surface where you don't have these 4 defined boundaries, how would you create a surface? Well, this is where we use the patch command. So patch command can take in any number of sides. You have to define how many spans you want to provide. So the higher the spans, the better it will be able to take the shape. But at the same time, it might create some ripple effect. So you have to be careful about the span counts. But once you have defined that, it will fill up the gap. Okay. Keep in mind that the patch command still makes a single surface, but it trims the external part using the boundary curve that we have defined. Okay, so it still is a 4-sided surface, as you can see. Now, not just that. The advantage of the patch command is you can actually provide some internal shapes, for example, a point or curves, as the parameter to control internal depth of the shape. Okay, so if you look at the top example, we have a surface where we cut out a hole and I patched it using the patch command, and you see the EMAP effect of that, like a shiny effect of that surface. And you can see it works amazingly to cover up that hole. But in the bottom case, I did the same operation, but this time I added a point as well as the input. And using the point, I could create this dimple effect. Okay, so here is the application of the same texture. So I have a couple of boundaries, the surface boundaries, and I have provided a centroid on each of these boundaries. And I have moved the surface boundary slightly in the z-axis. And using that, I'm able to create these kind of dimple fading effect. Okay, so let me just quickly recap. Why should we use the patch command? It works with non-4-sided boundary. As you can see in the previous example, these were circles. Handles non-planar boundary as well. So you can have non-planar boundary curves and it will still create a patch. Accepts internal points or curves to control the depth or height of the surface that it makes. And it outputs a degree 3 surface, which is manufacturing ready. It can easily integrate in our manufacturing pipeline. Okay, does that make sense to everyone? Any questions, any doubts? Please let me know in the chat. So now we will see a hands-on example to recreate this texture using Rhino and Grasshopper. Okay, so I will be providing you this lug shape, which I have downloaded from the official web page. So that dimension remains the same irrespective of the Apple Watch you use. It's just that the cross section is something you can modify based on what is the size of the Apple Watch. Okay, so I will be providing you with the curves. We just extrude and create the cross section shape. I explode the model to isolate just the top surface, and I will then tween some curves. I will use the curves, the tween curves on either bends, and I will use the same patch example I showed you to create these fading patterns. Okay, and once we have the flat pattern, we will see how can we deform it for visualization. Okay, So let's go ahead and open Rhinoceros. I'll go ahead and open Rhino. I'll be using Rhino 8. So I'll give you a moment. Meanwhile, you're opening the Rhino in your computer. Let me quickly also take you through our foundational Rhinoceros masterclass. Okay, so this course is beginner and intermediate friendly. So you can join our live courses on the weekend. So in this Rhino masterclass, you will learn how to create solid models. You will learn the concept of NURBS, curves, and surface. What is degree, span, G0, G1, G2 continuity. You will see examples of Class A modeling and how to create sub-D and mesh models. Okay, more about these courses at the end of the workshop. All right, so now let's get back to the file. I'll open Rhino. I'll go to the download folder. Okay, and in order to open the file, let's drag and drop it here. Let me just quickly see the questions meanwhile you are opening the file. So we have, okay, already, how long will the stream be? It's gonna be around an hour and 20 minutes, okay? You will be able to also watch it afterwards in the same link. Perfect. So I hope all of you are able to open the Rhino file. Okay, so like all of our past webinars, you will see that in your Rhino file, we have these layer tab. And as we go through the steps, I will unblock different layers. Okay, perfect. So let me first explain you how to use the patch command in Rhino. So I will zoom into this section. I have made a planar curve. I have made a planar circle within it. And I have a point that I made in the center and moved it in the z-axis. So I will first make a surface from planar curve. I will use the curve to split the surface, okay, so that I can remove this part. So you can follow this step in the next section. And now we will create a patch using this boundary of the surface and this point as the internal shape. So let's go to Surface Creation Tool, Patch. Select the boundary. Okay, you can use the curve or surface edge, doesn't matter in this case. Select the point as well and press Enter. It's gonna pop up the patch parameter. So I have been using here in this case 20 by 20 spans for U and V. Okay, you can see here. You can also control the stiffness. So the bigger amount you put here, the tighter the surface will be. So it will not be affected that much by the point. The lower value used, the more flexible the surface will be. Okay, so I'm just setting it 20, 20, 20 and press OK. Now in my Rhino viewport, you might see the surface normals in different direction. I will just flip it. Okay. So if I join everything, it will create a single poly surface, as you can see. Now, when you apply patch, it creates these 20 spans, and it might not look right if you are new to Rhino, but it's a high quality surface, so don't worry about that. You can always go to Properties and then disable the ISO curve preview of geometries in Rhino. It doesn't do anything in terms of geometry operation. You're just hiding these internal U and V spans. Okay. And lastly, I will ask you all to run a command called emap, environment map. Okay. So let's select the object and press Enter. So what this does is it reflects an HDRI onto the object, and this is going to give you a better approximation on how this product will look if you manufacture it or render it. Okay, so I hope you all were able to recreate this patch texture, a simple one, right? Everyone? Perfect. So now let me zoom out and let's go to layers. And we will be unhiding the next sublayer. multiple patch. So here I'll explain you how can you create not just one, but many patch textures. Okay, I'll first show you in Rhino, and then I'll show you how to make it in Grasshopper. Okay, so the first thing that I did was, just like before, using the curve, I made a planar surface. Using the planar surface, I split the surface using these curves, which is then going to give me a couple of trimmed surfaces. I extracted the centroid of these surfaces by making a point around the center. You can also run a command called area centroid. So a quick way to find the center point of a geometry. Okay. And after that, I will extract the boundary curves. Okay, because we don't need the surface, we actually need the boundary curves. So there is a command that you can use to extract the boundary curves easily. You can either use dupe face or dupe edge. That is going to give you one curve at a time. Or you can use this command called duplicate face border. This is going to give you directly a closed curve. Okay, so you can use either. And I have now a set of curves with the centroid points. I will take these centroid points and I will move them in the z-axis to control the depth of the texture. Okay, so let's zoom into this section. Okay, if you are unable to zoom to a specific object in Rhino, you can always select the object and you can click here, zoom selected. So if I run the patch command in Rhino, surface creation tool, patch, curve, point, enter, and again, curve, point, enter. Okay, the backface setting in my case is magenta color, but don't worry, it's just a property of a NURB surface. You can run flip command, and this is the end result. Now, it is easy to make in Rhino, but if you have to do this process for tens or hundreds of pattern, it's a tedious process. So this is where we will use Grasshopper so that we can first create many variations, many repetitions in Grasshopper, and we can dynamically change the settings and see how it looks like rather than manually sculpting it one by one. All right, so let's check how to do that. So I will launch Grasshopper. So if you have never used Grasshopper, also please let me know in the chat. So to launch the Grasshopper interface, in the command bar, write Grasshopper. Okay, or you can also click on this green icon. It's going to take a couple of seconds. And then you should be able to see this floating window on top. Okay, so this is a floating window on top of our Rhino interface. Let me quickly take a look at the chat, sorry. Okay, what does the sample point factor affect during the patch command? You just leave it to 1. Yeah, the default setting is 1. It's basically, if you use lower number, it will be kind of like recreating many points on the curve so that it can use that as a reference to build the patch. So the lower number will give you more accurate patch, okay? But it will also give you more spans and more deformation on the surface. And if you use a bigger amount, you will get a smoother surface, but it might not adhere properly to the edges, okay? So 1 works fine in most cases, but you can also change that if you don't see the right result, okay? Dupe border and dupe face border. I think dupe edge and dupe face border. Dupe edge lets you extract a single boundary curve, like a single edge, whereas dupe face border lets you extract the entire face at a single operation. Okay, so let me go back to Grasshopper. So if you have never used Grasshopper, which I can see some of you are, you have to dock the Grasshopper window on the right-hand corner like this. Okay, and let me minimize the interface so that I can expand the panels more or less till half of the screen. This is just because you can now see whatever happens in Rhino centered in the camera, rather a part of the interface hidden behind your Grasshopper window. Okay, so I'll dock it back. So let me show you how can you rerun the patch command, but now in Grasshopper. Okay, so if you have never used Grasshopper, you can first create a curve container so that we can import this curve inside Grasshopper. For that, you just have to go to the first tab, Params, Geometry, and then create a curve container. Okay. Now, the curve container is going to be empty. There's nothing inside. That is why it's orange in color. In order to reference that curve from Rhino to Grasshopper, you have to right-click on the container and choose this option called Set One Curve. You will notice that in Rhino, it's asking me to select the curve, which is going to be this blue curve. In order to verify if the curve has been properly selected, when you click on this node, you should be able to see the curve turn green in color. Okay. Now, let's see the patch command. Okay, so let me go to Surface tab because patch is a type of surface. Freeform surface, and here you will see the patch input. Okay, the command is red in color by default because there is nothing inside, so it's waiting for an input. So it has multiple inputs. The first input is define the curve for the patch, just like in Rhino. When you run the patch command, define the curve for the patch. So let me select this curve. And you can see automatically it runs with the default span count of 20, default flexible parameter, and default trim input. Okay. Now, in order to render it, properly see the patch output, let's create a component called display preview custom preview. Okay, so that we can render the output. Perfect. Now, let me select this point and import it in Grasshopper as well. So it's beneath the surface. So just like before, we need to create first an empty point container. So geometry, point, right click, set one point, select that point, and connect it here. So now can you see, just by providing these two inputs, okay, you're able to create the fading effect. So let me know if you were all able to at least recreate a single patch. Let me see the questions in the chat. What's the difference? Blah, blah, blah. Okay. I really like the, sure, I'm using OBS recording. Okay. Perfect. All right. And yeah, we have now 100 live viewers. Thank you all for joining. Awesome. So once you are able to create a single patch, now in order to create two patches simultaneously or 20,000 patches, it's the same process. Okay, so let's see how we can apply multiple patches. So let me disconnect the cables. In order to disconnect the cables, you can press and hold Control, and then when you make the cable, it disconnects it. Okay, just normally connecting connects it, but while pressing Control, it disconnects it. You can also see there is a red arrow next to the cursor when you press and hold Control. Okay, so let me disconnect these two cables. Now, let me delete the containers and let me recreate a curve container like before. Now this time I will import not just one curve, but multiple curves. Okay, so in order to do that, right click, set multiple curves. Curve 1, curve 2, press enter. There we go. Okay, now here is a problem. You need to understand that the Grasshopper components, they work as per lists. Okay, so what is happening at the moment is we have a single list of curves made out of two inputs. Okay, in a single list we have two curves, and when you connect it to the patch command, it is using both the curves to create a single patch. The equivalent of this in Rhino will be when you run the patch command in Rhino, you are selecting curve A and B simultaneously, right? So it's not going to make two separate patches. If you want to make two separate patches, you have to run the command twice in Rhino. Once for this curve, repeat for the second curve. Okay, so as you can see, I ran the command twice. So in order to do the same thing in Grasshopper, I have to basically put these curves in two separate lists. Okay, so there is an operation we can do here which puts each item into a new list, and that operation is called graft. Okay, now in order to learn more about these lists and data tree, I highly recommend checking our Grasshopper masterclass. This is also ideal for beginner and intermediate users. So if you have never used Grasshopper, or if you have used Grasshopper but you don't understand what is graph, what is flatten, how to match the data hierarchy, you will like this course. Okay, so we'll start from the very basics, like how to create components, what are the input parameters. We will learn Boolean operations. We will learn how to apply fillet, parametric modeling, data tree and list management. We will also learn attractor workflows to create simple 2D patterns. And we will also learn how to create a sub-D texture at the end. Okay, you can know more about these courses later on at the end of the presentation. So let me go back to the Grasshopper file. Now, we have these two curves in a single list. So let's go to sets, tree, and we have a component called graphed tree. Okay, another way to find these different components is to double click anywhere on the interface and look for these components. Okay, so when you double click and write G, it will start to suggest you components starting with that text. So graft, graphed, and you can create the component. Okay, so let me connect the curves in the component, and then if I show you the output, now can you see we have the curves in two separate lists? Okay, this component that I'm using is called a panel. You can go to params, input, panel. Okay, and you can see now we have two separate lists. Yes, using the component or right-clicking and grafting is the same thing. Okay, so let's connect it here. And now, can you see we have two separate patches? You can also hover on the component, and you can see it's telling me this component ran twice. It ran 2 times. So let me define the 2 points as well as the inputs. So let me create a point component, right click, set multiple points, point 1, point 2, and press enter. Okay, so if I connect it as it is, you will notice it works, but it's trying to use the 2 points simultaneously for a single surface. We have to do the same process again. We have to run the graft command for these 2 points, okay, so that for the first curve, I'm providing the first point. For the second curve, I'm providing the second point. And now you should be able to see the 2 fading patterns. Okay, I hope you all were able to retry it. So let's try this with me. Let's right click on the curve container and clear the values to delete the previous inputs. And let's right click on the point container and clear the values to delete the previous inputs. So if you zoom to this section, we have now 1, 2, 3, 4, 5 curves and 5 points. So let's try to reapply the same logic here. In the point input, right click, set multiple points. So just remember the order: 1, 2, 3, 4, 5. Press enter. Right click in the curve input, set multiple curves: 1, 2, 3, 4, 5, and enter. So can you see now, if it's 2 curves, 5 curves, 50 curves, the same logic is applied. Okay, so the trick in Grasshopper is that if you want to run a command multiple times, you need to understand how lists and data tree work. And based on this, the component can run n number of times. So in this case, the component is running 5 times, creating 5 separate patches. Okay, is it working for everyone? Any questions? All right, so once you have made these patches, how would you convert it into Rhino geometry? Because if you see, or if you try to select the surface in Rhino, it doesn't exist. So all the geometries we make in Grasshopper is kind of like phantom geometry or cache geometry. So in order to convert it into a geometry which Rhino can understand, we have to perform an operation called bake. Okay, so you right click on the patch output. You will see this option called bake. Okay, so you can define which layer. By default, it's in the default layer. And if you're baking multiple objects, you can group it. So it's easy to move it around, and press OK. So now we have the same geometry in Rhino. Okay, you can at the end join them together, and you can also run emap to see the quality. So I hope you all were able to try it out. Okay, now you can also join the geometries directly inside Grasshopper. So the command that you would use is called join BWrap surface freeform, or sorry, utilities. And we have, I cannot find it, so I can double click and look for it. Join BWrap. It is situated at, it was here, utilities, join BWrap. Now, if you connect it as it is, it will not work because it's trying to join each of these surfaces separately. So I have to join them together. I have to first put them in a single list. How? By flattening the list. Okay, so sets, tree, flatten. Flatten is kind of like the opposite of graph. If you look at the icons, this is kind of like creating all the branches, whereas this is creating new branches. So let's flatten it first. So now it's a single list, and now we can join it, and that is the final output. So this is the entire workflow. You can also change the flexibility parameter to make it more flexible by adding a number slider. So just double click and write 2.50 and connect it to the flexibility input. So you can change the flexibility of the file. Okay, so let's say if I set the flexibility to 5, we get this output. In order to properly visualize it, you need to hide the previous nodes. Select them all, middle mouse button, hide. So if I bake it, you can see we have a single output. All right. So with that said, now let's look at the Apple Watch example. Go ahead and unhide layer 3. Okay, so I'm first defining the watchlet shape. I'm extruding it. Okay, I'm extruding this, and I'm intersecting the two geometries. So you can go to Boolean intersection. This one, which gives us this end result. And just like before, I will hide the ISO curves. In the Properties tab, hide ISO curve. So I've already done these steps for you. I'm also writing the steps at the bottom so you can later on watch it and understand what's going on. Let's unhide the next step. Okay, so how are we going to isolate the surface where we want to apply the pattern? Okay, so you first take the geometry, explode it. So we just need the top part. And you will also notice that in each step, I'm moving the geometry by 50 units. This way, if I need to recover any geometry from anywhere, I can just move it by multiples of 50. Okay, so we explode it, and we now have the isolated surface. So now I would like you to zoom into this particular surface in layer 4. Okay, this one, select and zoom selected. Or you can also go to the top viewport, and you can see this one from the top viewport. Okay, so this one where we have draw curve input. All right, so now I'll show you how you can create the same effect of what we did here, but in case of this example. Okay, so here we needed a couple of boundary curves. We need a couple of centroid that we can move in the z-axis. Okay, so in order to recreate this pattern, okay, you can go to the download folder and drag and drop the second Grasshopper file. Okay, so this file already contains the end result, but I'll take you through the steps. Okay, how can you make the pattern? I'll wait for you a moment. Let me know if you have opened the Grasshopper file. It's easier to see it in the top viewport because in the parallel viewport I have the shaded mode, but you can switch also to wireframe mode to see the 3D effect. But easier would be just top viewport. Okay, so this was the first example that I showed you to create a single patch. Now let me take you through the steps of making multiple patches here. All right, were you all able to open the file? If I have 50 or 100 points, I have to select them one by one? No, because now you will see how we can make the centroids and the boundary curves automatically. All right. Okay, let's go. So what I have done here is you can click on this button so that you can only see the effect of the selected node. So I imported that surface in Grasshopper. I took curve A and curve B and I made tween curves between them. Between this and this curve, 12 curves. Okay, this is to make intermediate curves between the two shapes. And I did that using the tween curve command in Grasshopper. I used the surface, the tween curves, to split the surface into 14 different fragments. Okay, let me quickly show you the effect of these trimmed outputs in Rhino. All right. So now we have the trimmed surface like before. Then I selected the centroid, as you can see easily. And I selected the curves. And you can see there are curves where we have 4 boundaries. There are curves where we have 5 boundaries. There are curves where we have only 3 boundaries. Okay, so this is the advantage of using the patch command. The total number of boundaries doesn't matter. Okay, so I am taking the centroid and I am moving them in the z-axis. Can you see it here? I'm moving them in the z-axis. This is to create the depth effect. Finally, I'm patching it all together. Okay. And joining them as a single polysurface. In case you see that this is not joining as a single polysurface, you might have to increase the span counts. Okay, you might have to reduce flexibility, or you might even have to modify your Rhino's file tolerance. Okay, were you all able to understand the steps? If you want, try this with me. Select the green curve and try to slightly move it somewhere else. You will see that after a moment, it updates to the new position of the texture. You can also change the number of cross sections. So you can set this number to a lower number or a higher number. Now be very careful. Don't set the number to 50 or 60. It will take a while. So it's easier if you double click on it and set this to maybe 15. And you can see it automatically updates. You can also modify this shape in different manners and it will take care of the rest. So as you can see, this is a dynamic system. You can see the results in real time. Yes, you can also apply. This is actually a curved surface if you think about it. This is not a planar surface. Okay. But yeah, if this surface was even planar, we could also apply the pattern without any problem. You can also modify the depth if you want to create a more pronounced texture, or you can set it to a lower number if you want to create a subtle texture. Okay, I hope you all were able to recreate it. So once this is done, you can bake the result, which is what you see on the right-hand side. Let me go back to Rhino, and I will join everything else together. This is going to give us a solid poly surface. You can hide now the iso curves, which I have already done in the next step. All right. Now I will repeat the same process, but for the other side of the strap. Let's unhide the next layer. Same things, as you can see, same process of isolating the surface, same set of curves. And now let me show you how you can import this other curve. Okay. In order to use this other surface and other curve, you have to first import the surface, the one that we have at the bottom part. Okay, so instead of this surface, I have to import this one. You right click here, clear the values, and now you import this surface. Okay, now you can see it works, but as these two curves for the tween are still here, right? You can see that it's only splitting with the curves here, but we have to switch it with these curves. So let me select the first curve, which is here, and the second curve, which is here. I will change the number of sections to maybe 10. And there you go. Okay, so we just had to import these three inputs and it's done. Yes, you can also use it in cylinders. How do I know the order between point and curve is correct? You need to understand that, and it's a very good question. You are wondering, how does it know that the first set of curve belong to the first point? So if you think about it, when you take your first surface and you extract its centroid, at which index will you find the centroid? So the centroid belonging to first surface will appear in the first index. The centroid belonging to second surface will appear in the second index, third, fourth, and so on, right? So the same logic is automatically created because you are making the additional geometries from the parent geometry. So you don't have to worry about the order of the curves. It could be in any random order, but the points are also generated in the same random order. Okay? Perfect. So you would bake, you would have the final output, you would join everything, and you will end up with a solid poly surface. So let me minimize Grasshopper for a moment. Let's unhide the next steps to add the holes. So the first thing that I did was split the geometry into two and mirror it. Okay, so that we have pattern on both sides. I made some curves which you can then extrude. This curve which you can then revolve. Okay, and these curves which we can also extrude. So I've already overlaid them, and now you can apply Boolean difference. From here, using that. From here, using these cylinders. Okay. And lastly, you have to join them together, Boolean union. Okay, so that is the final output. Yes, it is possible to apply the pattern on the curved surface. Let me quickly show you here. So imagine if I simply import a curved surface, more or less of the same dimension. Let me change the height and make it non-planar. Okay. And let me see. By importing the surface. So can you see it still works? Okay. It's just that when you project the curve, the pattern, like the curve might not be projected properly, but as you can see, this still works. Does that make sense? Okay, so the curve the surface can be non-planar as well. That was one of the advantages of using this patch workflow. All right. So let's go to the 7th layer, deform. Okay. I'll show you about the cylinder one just in a moment. So now how can we take the flat strap and then apply it here and curve it? Okay. So we will be using deformation tools. In Rhino, we have deformation tools, and we have tools like flow along curve. So what it does is it takes a geometry that you want to deform, it takes a base curve, a target curve, and it deforms the geometry by literally taking the base curve and stretching it to fit the target curve. So let's try it here. Flow, geometry to flow, press enter, base curve, target curve, and you can see we have deformed the geometry in its final place. You can try the same on the other side. Flow, geometry to flow, base curve, target curve. Okay, so if you go to the rendered mode, you can see the final output. Okay, and if you scroll a bit to the right side, we can also define its final resting position. Just be careful, this end of the base curve corresponds to this end of the target curve, okay? Or the front part corresponds to this front point, okay? So let's rerun flow along curve, object to flow, base, target. Flow along curve, object to flow, base, target. Not necessarily. I mean, that would give you more predictable result, but if you run the command, there is this option called stretch. Okay, so if you enable it, it will make sure that the two curves are stretched to the same length. Okay. So were you all able to try it out? Any questions? Okay. Perfect. Awesome. So let me go back to the shaded mode and let me unhide the last layer called final. So this is your final assembly. You can also run emap to see the overall output. And you can see we have made this fading effect in Grasshopper and Rhino quite easily. Okay. How to bend the exact long for the wrist. I mean, what you can do is if you turn off the stretch option, it will automatically stop until it reaches the length. Okay, so here you can even see that it's probably a bit longer than the base curve. So yeah, the flow along curve command will automatically stop if the stretch is turned off. How did I create the curve line in the first place? I just model it manually. From the right viewport, I sculpted it slowly, tried some variations, and then stopped when it was working. Okay. Now let's unhide the 9th layer. When you click on the, so I have a question here, how to set which end of the base curve corresponds to which end of the target one? It depends how you click. So a curve has two ends, this end or the other end. So if you click on, let's say, this end to this end, the flow command will happen the opposite way. If you click on this end and this end, it will happen in the predictable way. Can I smooth the edges? Now it has 90-degree angle. Yeah, you can try with the fillet command. It might fail, but let's try. Okay, I would probably use a different technique, but let's see if it works. We can apply a micro fillet. So it fails. Yeah, so it's not gonna work in that manner. There's another way I can do it, which is literally duplicating the edge. Joining as one curve. Rebuilding it with a lot of control points. Piping it with our desired radius value. And then splitting the geometry with that pipe. And then I will be able to blend the two surfaces. I will have to chain the edges. Position. I think it has automatically done that. Okay, and then we can use some additional cross-section shapes. And slowly I can recreate the blend shape. Okay, that is one way to do it. Yeah, you can use less radius value. Anyways, so let's go to the V2 layer, 9th layer. So here I'm showing you a similar workflow, but on a different texture. If you open your Grasshopper file, we have the curves, okay, that I offsetted and then created the intersecting curves here using curve boolean. Okay, so that is the curve that I'm importing here. I'm creating a set of points. Using this workflow, I'm using a staggered distribution of the points. And then creating some circles, projecting the circles back to the surface, splitting the surface. So we have the outer chunk, which is this one. And we have the internal surfaces, which are here. I'm extracting the centroid, the boundary curves, moving the centroid in the z-axis, and then patching it all together. At the end, we have all the 98 dots, and we have the one outer surface. We will bake them together, move them, and join them together. Okay, so that is the final output. You will join it with the remaining shapes, and that is the end result. Okay, you will do the same thing on the opposite side. Just be careful when you switch the surface. You can also disable the solver. This way you don't calculate anything unless you play it again. Okay, this is going to save you unnecessary crashes when you switch the sides. All right, so let's unhide the next layer where we will add the additional holes on the model. Just like before, we will have the Boolean difference. With the holes, and we will join that part. Okay, let's unhide the second last layer for deformation. Okay. How do you match that pinhole? I just baked the circles, and then I used these circles and offsetted them a bit. Okay, so that way I have exactly the location of where we should put the circle. Okay. All right. So now let's go to this section. Okay. There is a password on the cluster. Yes, because this is a complex workflow that we explain in the advanced texture workshop. I'll talk about it in a moment. All right. So once we have unlocked the 11th layer, let's see the same deformation workflow. Okay, so let's go to deformation tools, flow along curve, object to flow, base curve, target curve. Similarly, object to flow, base curve, target curve. And for the curved shape, you can do the same thing. Flow along curve, object to flow, base curve, target curve. And similarly, base curve, target curve. Okay, so that is the final output. I hope you are all able to try this one as well. Okay, you can also use the staggered distribution from Lunchbox, which can create a similar effect. Okay, but this is a cleaner one. But you need a bit more explanation in order to understand what is going on here. That is why no point in explaining it at the moment. All right, so this is the final output. You can unhide the last layer, and this is the final output of the dot pattern, but using the same approach. Okay, so here you can compare the two outputs. All right, I hope you all were able to try it out. Any questions? Everything worked. Okay, thank you very much. And you can use the code, of course, in your projects. And this is just the beginning. And let me quickly take you through the next part, which is the, okay, I have questions you mentioned earlier. The degree 3 is manufacturable. Does it mean minimum degree 3? Degree 3, the advantage that we have is that even if the curve or surface is multiple spans, within the span we have curvature continuity. That is why it is ideal to model your designs with a degree 3 curve or surface. We already get internal curvature continuity between the spans. Okay, it's not necessary, but it's going to give you, or it's going to give you a surface that can easily enter in the manufacturing pipeline. When this 3D model needs to be produced, do you move on to drawing and sizing, or is it necessary? Do you know approximately how the mold making process takes place? Yes, in fact, I have some experience. I have worked on some of the products that are in the market. So it's a bit difficult to show you, but there is like a pattern that I have here on the siren. It's a bit difficult to show you. Yeah, you use Grasshopper to create these patterns. You use a step file, export it um, as a native CAD file for the suppliers CAD package. So this was made in SolidWorks, but I imported it in Rhino and Grasshopper, applied texture, and then exported it back as a step file. Flow command is also in Grasshopper, as I can see. It's just that it's easier to run it in Rhino because in Rhino, if something fails, you can press escape to cancel the command. In Grasshopper, however, if something fails, it can crash your Rhino and Grasshopper environment. That is why I prefer to run the command in Rhino. And it's a bit faster as well. Okay. I saw your LinkedIn post about the iron. Super interesting. Thank you very much. Is the third strap also made with Grasshopper? Yes, I'll talk about that in a moment. Okay. So let me quickly take you to the next part. Okay. And that is rendering the watch in KeyShot. I'll show you a very small trick. Okay, it's not going to take more than 3 minutes. We will import the KeyShot file, and I'll show you how can you create this nice beam texture. Okay, if you don't have KeyShot, just wait through 3 minutes. I'll explain that, and we will go to the next section. Okay, so let me open the KeyShot file. Okay, meanwhile you're opening that, if you use KeyShot for rendering, you can check our KeyShot Rendering Masterclass. You will learn how to create PBR textures, light settings like HDRI and physical lights, camera settings, procedural materials, and part and camera animation. Okay. So this is our KeyShot environment, and I use this for most of my renders. So the first thing you can do is double click on the sphere to open the material setting. Now I have already made the light. Okay, I will convert this plastic material into a spotlight. Okay, so you can do this here. Go to type, change the material type from plastic to metallic to spotlight. So it's now pointing a light towards the watch. You can change the color of the light as per requirement. Okay, you can also change the beam angle. And a bit of fall off. Okay, it's gonna smooth the corners. So let me select this one, which I already made. Now, if you want to create a nice fading effect or kind of like a highlight, what you can do is select your sphere and change its scale. Okay, so let me select the sphere from the list. Turn on the move tool. Okay, and just like in Rhino, we have the gumball. In KeyShot also, we have this gumball. Okay, so in KeyShot, if you enable the scale gumball, you will notice that there's this scale tool, which I can use to scale the light source. Okay, so more or less I can leave it to 0.1 or 0.15. So if you want to see the effect that it had, go to camera and switch to these different cameras. Okay, so here you will see a nice detailed view of the pattern. Okay, but with that, okay, with that highlight, and I can change it here and fine tune the effect. Okay, so you can create this nice highlight using the spotlight material. Okay, I have also made it already for you. So if you unhide this layer, you can check it out. Okay, just change the color of the material. Anyways, so let me close the file for a moment. Okay, so I hope you were able to recreate the pattern using the patch command, and you also saw a variation of it. And as I mentioned you earlier, the files that we make here are no mesh displacement, but rather NURBS files, which we can export easily as a step file. Okay, and it can easily enter in our manufacturing pipeline. So you can make injection mold from it, and you have the sufficient tooling data extracted from the NURBS file. Okay, so we would really encourage you all to create your own textures and variations and maybe apply it on different shapes so that you can also share it with us on our social media. We have our Instagram account, we have LinkedIn, so please tag us on all your creations and variations, and we will share it with our audience as well. Okay, quickly, I'll take you through our other advanced workshops. So we have these two courses, which is ideal for anybody who is already experienced in Grasshopper. But if you have never used Grasshopper, you first have to start with our basic Grasshopper course. So the advanced parametric texture workshop is ideal if you would like to create textures for manufacturing. You will learn how to fade the textures with G0, G1, G2 continuity. You will learn how to create textures on polysurface, learn all the design for manufacturing criteria, like how to demold parts. Okay, so it's a live workshop where I'll take you through the process of creating these textures. Apart from that, we have the computational design workshop. So if you use lattice structures, if you want to create 3D printable files, this course is for you. So you'll learn how to create footwear lattice, topology optimization, data-driven design, and optimizing designs with machine learning. You will also see generative design. So for example, this pattern that you see is something we teach in our computational design workshop. So if you want to learn how to create this fading effect of a lattice structure from solid to these gyroid lattice, you can check our computational design workshop. Okay. Hope you were able to open the other files. Let me know if you have any questions. How can I render in KeyShot with a hand? I will recommend you to look at different mockups, because in KeyShot you can provide like a front image or a back image, so you can maybe create your own picture and put it as a background image. Okay, and in the background image you have the object in front and you can render it in context. After that, in Photoshop, you can fine tune it. Maybe you might have to hide some parts of the object so that you can see your hand in front. Okay, so that is something you can do by adding a front image. All right. Now, before I take more questions, quickly let me explain you. We also provide training for companies. So if you are working in a company and you don't want to join our weekend courses, these courses are during the weekdays, and we can also create bespoke content for you guys. So if you model, let's say, just water bottles or maybe computer mouse, we can create custom bespoke texture workflows so that you can tackle those issues in your company. Apart from that, you can check our portfolio page where we share constantly all the project works from our ex-students, because once you join our course, you have to do a final exercise in order to achieve the certificates. So you can see these are some projects from our Rhino course, from our texture workshop, from our computational design workshop. You can also check our past webinars if you haven't watched them. Okay, you can also see in YouTube in streams these past 7 webinars, and you can also download their files. Lastly, you can check the dates for our upcoming courses in the calendar tab. Okay, so we have the next courses for Rhino, Grasshopper, texture, KeyShot, and computational design here. Feel free to reach out to us if you have any doubts, any questions, any suggestions about future webinars, and we will do our best to help you out.